is to knowledge on the data engineering side, what the technologies we are working and all these things. So before getting into the topics, let me tell you what topic I am going to cover in this video. The very first topic which I am going to cover is what is big data. So as a data engineer, you are going to deal with the big data day-to-day life. So just have a plain definition: what is big data, what you can define a big data, what is big data, when you can say what is big data and which is not big data. Okay. And the other topic which I'm going to cover will be a difference between monolithic versus distributed architecture, because as a data engineer you mostly deal with the distributed architecture, but in order to understand distributed you need to understand what is monolithic. Okay, that's why. And the last topic which I'm going to cover regarding the overview of a Hadoop system. Okay, Hadoop is a legacy one, but still we need to understand the Hadoop in order to understand the Spark. The Spark is currently we are still using in our industry for a distributed processing. Okay, so without further ado, let's start the video. So our first topic is what is big data. So big data is something data which is massive, consist of variety and come with a different frequency in our system, that we call big data. If you wanted to define a big data, you can define this big data with 3 V's. So each V consists of, like, first V, volume. When I say volume, it means some terabyte to petabytes or more. Okay, that then we call it's a big data. Okay, we also deal with many times with the GB of data. Okay, that we don't consider as a big data. Okay, so mainly terabyte or above will be called a big data system. Below that also come under the data engine domain only. Okay, but it is the usual data that we get most of the time. Okay, so the second V is variety. When I talk about variety, it means how different kind of data is coming into our system. Okay, for example, CSV file, flat file, Excel, PDF, streaming data, different kind of data which come into system, different variety of data. Logs files also comes from, some files come from APIs as well. So that is a variety of data types coming. Okay, and the third is velocity. So when I talk about velocity, it means how frequently the data is coming into our system. For example, how data may come daily, every minute, every second, every month, every week. Okay, so how frequent the data is coming, that we call velocity. Okay, so with these 3 you can define your big data system. A big data is nothing but which cannot be deal with the traditional tools which having huge amount of volume, variety of data and velocity of data gradually increase or decrease, that we call a big data system. Okay, so now coming to the second topic, that is monolithic versus distributed system. So when I say monolithic versus distributed, let me write it down. So example of our monolithic system: mobile phone, laptop, talk okay, these are the example of monolithic system. When I talk of monolithic system, it is a single system that can be vertically scaled. Like for example, in the CPU you can increase the RAM, you can increase the processing, you can increase the storage. Okay, you need to buy a physical drive, you can add it, okay, directly. So it is a vertical scale up. Okay, so when I say vertical scale up, you can just, if you need some more storage, you can just add some SSD or hard drive, you will add up the storage. Okay, if you need more processing, you can add RAM or more processing power into your CPU, so it will increase the processing power as well. But the major disadvantage of this approach is that the amount of hardware you increase, it's not proportional to the processing it will increase. Okay, so there is always some difference, like you increase twofold processing of your monolithic system, but the output you will get only 1.5 time or below that also many times. Okay, so it's not mostly feasible in our big data environment. Okay, that's why if you, whenever you deal with the big data, you mostly heard about the distributed architecture. One is the Spark. Okay, Spark work on a distributed architecture. So when I say distributed, it's a horizontal scaling. For example, in a back end somewhere you will have a certain server. Okay, you are running some process. Okay, and after some period of time you feel necessary to increase some processing power. So what you can do, you can just go and buy a processing and backend. They will just stack up, not just horizontally, just light, add some processing, and you are ready to go. There is infinite scope of increasing the distribution processing, but in the monolithic system you can increase up to certain mark, not beyond that. And also it's also has single point of failure. If that process fail, everything will fail. But in distributed you will have some backup, because there will be a different machine, right? For example, machine 1, machine 1, machine 2, machine 3. So for example, if this machine fail, still you will have your backup into this machine 1 and machine 2. If these two fail, you will have certain backup. So it is very rarely that all the machine will fail. Okay, it is more suitable, reliable, and you can have distributed processing. For example, if you have one single file, okay, 1 TB file, you have, for example, 10 1.5 GB file you have. Okay, so what it will do, 500 MB file will go here, 500 will be what it will be, it will just split that file into 500 GB of data. Okay, and 500 will go here, 500 will go in machine 2, and 500 will go in machine 3. Okay, it will be distributedly processed, it will take less time also, and will merge it, and you will get a output after it processing. Okay, so that stuff, kind of stuff, happen in the distributed architecture. Okay, I guess you understand the basic stuff. So let's come to Hadoop. Okay, so what is Hadoop? Hadoop is a distributed system to process big data. Okay, it was previously used before Spark came into the picture. Okay, it have majorly 3 components: SDFS, the second one is MapReduce, and the third one is yarn. Okay, HDFS is Hadoop Distributed File System. It is a storage of our Hadoop system. MapReduce is our processing, and the yarn is the resource manager. Okay, it manages the resource for the clients, okay, the people which are using. So it's kind of a middleman. Okay, for example, I want certain processing, okay, and there are 3 4 developers, so it will prioritize as per the need. Okay, the yarn will prioritize and it will allow some map reduce processing to that particular user, okay, as per the requirement, or put some people on a queue. Once some resource get free, that will be allotted to you. Okay, like that it works. So if I talk about, so HDFS and YARN are still being used, but MapReduce has been absolute, okay, because there was certain drawback of it. Okay, actually what used to do, it was kind of slower than today's Spark. That is 10 to 100 times slower than the today's Spark. Basically it used to work like out of memory, like it used to write on a hard drive and again read it. That IO operation was more, that's why it was quite slow compared to a Spark. But when you compare to Spark, it in memory processing, okay, that's why it's more faster than its previous or I can say MapReduce. So that is why it has been absolute. But still we are using YARN or HDFS of Hadoop system, and now the new thing has come into the market, that is Spark. So in Spark we mostly deal with, here what we did, we kept HDFS like that only for storage, but instead of MapReduce we have take Spark as a processing, and YARN for a resource manager. Okay, so you can change this HDFS. Instead of this HDFS, you can use S3, Azure Gen 2 storage, or any other storage stuff you can use. Okay, it's not necessary you need to use this one only. In Spark, you can, it's a processing thing, it can be coupled with HDFS and YARN, so that's why we are using Spark. It is more user friendly and all this thing. You can use easily Python, you can use to manipulate data and all the stuff. Okay, so let's just give some overview of Hadoop architecture. Sure, one second, let me open the Paint. Okay, in Hadoop architecture, suppose these are 3 machines, okay, 3 node machine. So it's it you will call a data nodes. These are the data nodes. Node. Okay, so these data node are the machine which consist of your original data. Okay, so these are the separate machines. Okay, and there will be one more node called name node. Okay, so what name node will do, name node will consist of the metadata. Like for example, you have one single file 1, okay, of 1 GB. Okay, so what it will do, it will going to split that file into chunk of like 300 300 or 400 400 MB 400 MB and 200 MB. Okay, 400 400 400 MB. Okay, so what name would do? It will consist of a metadata, like which file one component of 400 where it is kept, in which node, node 1, node 2 or node 3. So this kind of metadata it will consist of. It won't consist of actual data. It is kind of manager which are managing this data node. Okay, so it's a very important component. So this is the architecture of a Hadoop system. This consists of data node and name nodes. Okay, I guess this is enough for the day one. Let's wrap it up, and later we can discuss more in depth about this. So thank you for the patient. I will hope for your feedback. Okay, please give me the feedback on the quality of the video. I know the quality of video is not superior or great as well, but still you can give the feedback so that how can I improve. Your suggestions will be appreciated. Other than that, please comment, like, share and subscribe as well, as this is my very first YouTube video. It will motivate me to improve in this area and give more knowledge in our data engineering domain. Okay, thank you, sayonara, bye bye.